Section 12.1 Sequences and Summation Notation. A sequence is a function A whose domain is the set of all natural numbers. The term of the sequence are the function values. We usually write a sub n instead of the function notation a of n. So the terms of the sequence are written as a sub 1, a sub 2, a sub 3, and so on. The number a sub 1 is called the first term, a sub 2 is called the second term, and in general, a sub n is called the nth term. In this example, we're asked to find the first and the 100th term of the sequence by using the formula. For the first term, we simply plug in 1 for n and get 1. And by plugging 100 for n, we find the 100th term of the sequence. The same way, by plugging 1 and 100 for n, we find the first and 100th term of c sub n. The same method works for t sub n and r sub n to find the first and 100th terms. A recursive sequence is a sequence that there is no simple formula to define the sequence, and the nth term of the sequence may depend on some or all of the terms preceding it. Here we want to use a recursive method to find the first 11th term of the sequence, where f sub n is the sum of two previous terms. We know that f sub 1 and f sub 2 are both 1. So the next term is 2, and the next is 3, and then 5, 8, 13, 21, 34, 55, and 89. The sequence is called the Fibonacci sequence, named after 13th century Italian mathematician who used it to solve a problem about the breeding of rabbits. In calculus, we are often interested in adding the terms of the sequence. This leads to the following definition. For the sequence a sub 1, a sub 2, a sub 3, and on, the partial sums are s sub 1 is a sub 1, S sub 2 is the sum of a sub 1 and a sub 2. S sub 3 is the sum of the first three terms. And S sub n is the sum of the first n terms. S sub 1 is called the first partial sum. S sub 2 is the second partial sum. And S sub n is called the nth partial sum. The sequence S sub 1, S sub 2, S sub 3, and so on is called the sequence of partial sums. In this example, we're asked to find the first four partial sums and the nth partial sum of the sequence a sub n equals 1 over 2 to the nth power. S sub 1 is 1/2. S sub 2 is 1/2 plus 1/4, which is 3/4. S sub 3 is basically S sub 2 plus 1/8, which is 7/8. And S sub 4 simplifies to 15/16. Note that each of the partial sums have a denominator of 2 to the power of the partial sum index, and a numerator 1 less than the denominator. So the nth term is 1 minus 2 to the nth. Given a sequence a sub 1, a sub 2, a sub 3, and on, we can write the sum of the first n terms using summation notation or sigma notation. The sum of a sub k from k equal to 1 to k equal to n. So the summation notation tells us to add the terms. K equal 1 tells us where it starts, and n tells us when it ends. In this example, we want to find the sum of k squared from k equal to 1 to k equal to 5, which is 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, which simplifies to 55. The sum of 1 over j from j equal to 3 to j equal to 5 is 1/3 plus 1/4 plus 1/5, which simplifies to 47/60. The sum of k from 5 to 10 is simply 45. And the sum of 2 from I equal to 1 to I equal to 6 is simply 6 2's added, which is 12. These are the suggested textbook homework problems and required ALEKS homework for section 12.1.